Okay, a couple of other things after you separate all the components. Sometimes, as we try to separate this one, for instance, I'm going to do something that I know is bad. This actually isn't so bad at all. I'm going to do something that I know is bad. I'm going to push it down, and now it's hitting these lines. And let's say I didn't notice it the first time. I'm going to do a quick check. Under verification, check design rules. And it says, holy cow, you found a lot of problems. You can see where they're all, these circles here and these circles here are all saying that there's a problem with the design. So let's keep pulling it down a little bit more and do another design rule check. So this is better. Now the only problems that we're getting are off on the right. So let's zoom in and see exactly what's going on the right. You can see I've dragged it over here. So let's just drag this wire here. And you can either run the design rule check by this button, or you can, it's the same thing by choosing verification check design rules. And now it says it's clean. And this is starting to look pretty good. I would still separate some of these wires out, but it's starting to look pretty darn good. Okay. You're not done yet. Before you're done with this, you probably want to increase the size of the widths of your power and your ground traces. So to do that, you'll go back to your schematic and you'll find where your power and your ground traces are. So here's your schematic, and I can see that on jack 2, pin 2 is a ground. I mean, I could have chosen that ground from lots of different places all over here, but jack 2, pin 2 seems to be a pretty easy way to do it. So I'm going to go now back to my other program, and I'm going to look for jack 2. If I can't, I know it's up here. If I couldn't see it, I could look on my list to the right and find jack 2, but I can see it's up here. And I'm going to pause my cursor over each pin. This says jack 2 colon pin 1, and then this is jack 2 colon pin 2. So anything connected to this pin is going to be ground, and I want to make it thicker to allow it to hold more current, because I know my power and ground will hold a lot of current. So I'm going to switch my layers to the bottom layer here so I can see where this line is. And then I'm going to right click it, and I'm going to change the width. You'll see different names here. You can change the trace or the net width. The trace is this particular wire here, everything here. But the net is not just the stuff on the bottom, but it's the stuff on the top too. And it's the stuff on the bottom that doesn't seem to be even connected to it because it's connected on the top. So everything in blue is the net. That's what I want to switch. Anything to do with ground. So I'll choose net width. And instead of by class, I'm going to choose a custom. And I'm going to increase it from its default 0.015 to, I'm going to double that to 0.03. And voila, it's instantly done. Now, you can see down here that causes a problem. It's too close to this. I think it would probably fail my design rule check. Well, it actually passed. It's too close for me. So I'm going to just drag that out a little bit to clear that. Same thing over here. This is too close for me. I'm going to open this up quite a bit. And same thing over here. I'm going to pull this via out. I don't know why I did that up here. Let's give it a 45-degree angle. Let's pull this out here and give it more room to breathe. Okay, that's looking much, much better. This angle is a little unnecessarily close. Let's pull it apart. And this too. It's just, why have it running so close? In fact, even better, let's have this whole wire go on this side, letting us breathe that much more. Same thing over here. Too close. Pull it apart. There's nothing wrong with having a T-bend. You just don't want to have a lone 90-degree bend. So there's our T-bend. That's fine. Okay, looking much better. Do it not only for power, do it not only for ground, but do it for power as well. That's better. Okay, now let's check what it looks like on the top. On the whole, pretty good. This is a little bit unnecessarily close. Okay, here's a good example. I can insert an extra bend here. I can right click and add node right there. And now I can just take this part and bend it away. Yeah, these two wires are still a little close. I can bend this bottom wire down. And now I've got, whoops. And now I've got some nice separation between everything. You're not done yet before, oh, and this is a little close. Unnecessarily close to that. Okay. Let's verify, check design rules. They're good. Let's check net connectivity. It's good, no errors found. And then the last verification is the bottom, compare to schematic. It says which schematic, and you'll navigate over to your printed circuit board schematic and you'll check it. And I promise you it'll say it's good too. Okay. Before you go and export this, you want to have some sort of labeling so you know which printed circuit board it is. You're never going to make just one printed circuit board. The first version will never be right. Something's not going to fit right. So let's add on the silkscreen layer information about what version you're on. This up here tells you where you're going to place stuff. So let's work on placing it on the top silk screen. And one of these options will be placing text. Find a blank area and you can say what project it is. This is the Eve project and it's version 1.0. And then escape will take you out of editing mode. If you want, you can click the arrow and move that around to some other place on your printed circuit board. I promise you, don't feel bad. You want to get your first printed circuit board out fast. It's going to cost $25 for maybe one printed circuit board and another $25 to have it mailed to you quickly. And then you'll find all the things that were wrong that didn't fit. And then you'll go out with your version 1.1 and that'll be a winner. Very last thing. You can see the outline of your printed circuit board in purple. A great tip to use is that printed circuit boards can be built upon really thick fiberglass if you want to, and you can make it part of the mechanical design, of your device. So for instance, we could make it a little bit bigger and place cutouts in it for robot mounting wheels and things like that. Then you don't have to have these things. They can be an integral part of your robot. It's a beautiful design. If you want to create more complicated cutouts inside here, choose your board cutout layer, and then under objects, choose place a shape and a rectangle. And now you can place a rectangle for cutouts. They can be incredibly complicated cutouts. And you can change the size of your board to be round or anything you want to as well. And this will create a cutout within your board.